They're nice. She doesn't sure know what's on either.
All right, so we got that going now. So we can have the video. Right.
Oh, I know. I'm like, it's really not bad. Okay.
All right, so here we are on the 2nd of July. So then the 4th, we don't have class. The 4th. In fact, the campus is closed on the 4th and on the 5th. And then on the 6th, my daughter's getting married. So I'm going to be kind of offline for a couple of days there. And then next week, we'll get back to relative normal. And we'll just keep going until we're done. How about that? So, the specifics of our schedule tell us that on the 25th of June, we had an exam number 2. And so our first order of business is to talk about that. Now, I did post the grades onto the textbook publisher site. For whatever reason, people always have trouble with this. The fact of the matter is, your grades are not actually on Blackboard. They are on the textbook publisher site. It's not usually hard for you to get to them. You just have to go to the place on the textbook publisher site which shows your grades. So if you have any question about how to get to your grades, I can answer those questions for you. But they're not on Blackboard. They're on the textbook publisher site, which is the same place you go to do the homework. So what I have done is I have put the grades on your test. I have the grade for the test itself. That's in green ink. And then in blue ink is your overall grade. Okay? So this is what it looks like. You have the test grade, and then you have the overall grade. The overall grade is circled. Okay? So then you'll know kind of where you stand. Now all these are online. They're on the textbook publisher site, but I'm also putting them on these pieces of paper so that you can have them. Right? So that you'll know where you stand. Now the reason why this is important is because of the things that happen when people take tests like this. All right? Basically, when you say, all right, what's the result of taking a test? Well, that depends on the person, certainly. And what we have here is a lot of contrast in the results. And so I'm going to put that up here so that you know where things are right now. So here are the test 2 grades. And here are the overall grades. Okay, so that you can see the difference between those things. So it is 6, 7, 0, and 9 over here. And then it's 8, 5, 5, and 4 over here. Okay. So there were people who did better on this test than they did on the first test. But there are also people who did not do as well. Okay. Now, if, let's say, you get an 80 on test 1 and you get a 60 on test 2. I'm pretty sure your math skills are okay here. What would be your average? 70, which would be a C, right? So you can have a C at this point. However, the trend is not encouraging, right? If you start with an 80 and you lose 20 points of grade and you get a 60, the next thing that might happen might be really bad. Okay? So what's happening here is that these tests are going to get progressively harder as we go. Test number 3 is going to be more difficult than test number 2. And so if you're in a situation where you're in the below C level for test number 2, then that's a significant problem because test number 3 is going to be more difficult. So something would have to change between now and then in order for you to do well on test number 3, or in order to you pass test number 3. Okay, now for some of you, it might be that you just had some things in your life that changed, and so then test number 2 was for you a problem where test number 3 might not be. However, for some of you, there's not things that have changed. Things have stayed the same, and they've just gotten harder, and it's just gotten more difficult. Now, I don't know everything about your situation. I do know specifically that there have been people who have talked to me about some of the things that are going on in their life, and it's like, okay, so you got things going on in your life, and maybe you were not able to come to class all the time. Maybe something else happened, all right? And I understand that. I was looking at some of my notes from graduate school a while back, and I saw some papers in there that I had copied from other students for my notes because I didn't go to good class. So I was in graduate school and I was missing classes. So I know how that works, but you know what? I looked at those papers and I had no idea what they were talking about. So that's the way it goes. The idea of how you can be successful in the class means that you're going to have to manage a bunch of stuff, right? And if your ability to manage all these other stuff outside of class, maybe that'll have an impact on your grade. Maybe it's just that you decided not to work on it for a while, but now you're going to decide to work on it. I don't know the answer to all those questions. What I can try to help you to do is to actually do the work and get through the stuff. And certainly I'm very flexible as far as when you do it. As long as you do it, that's okay. It's possible for people to retake tests. If you get below a 70%, you can retake a test. But if you have to take retake for test number 1, and you have to do a retake for test number 2, and you don't understand anything about what's going on, that's a problem, because you need to be able to learn that, and that's going to take a lot of time. So I don't know what your situation is, but I do know that this is a hard class, and it takes a lot of work for most people. And so then sometimes people are successful, sometimes they're not. And depending on the situation, maybe you get it, maybe you don't. But if you're in this low situation, notice that there's a substantial number of people here that are below sea level, but those people break up here. So that if you're like at a 60 or something %, if you really work hard, you might be able to do better. And keep doing your homework, and all those things are 100%, and those all work together in your favor. So just because you got a low score on this test does not mean that you're ultimately doomed to failure. But if it's a problem and there aren't solutions for you, then you have to consider your options at this point. All right, so when we talk about this particular test, and we ask the question, how much of this test is going to be on the next one? Okay, we are going to be talking a lot about z-scores and their meaning. So you need to understand the idea of the z-score and how it's related to the idea of the area. So that's a big thing that's going to happen again. The concept of binomial probability, we won't be doing a lot with that, but the concept of binomial probability is still going to be with us. Things like the tree diagram, not really an issue. Discrete probability distributions, no, not much. But the mean and standard deviation and the empirical rule, yes, we are going to be talking about things that are related to that. So those are some of the main things that you need to understand. All right, so I'm going to hand these things back, and then we're going to go over them, see if there's anything that you want to do that.
Sorry, maybe that person's like, maybe it's too bad. There's one shift. I don't know if she was saying that was really characteristic. Yeah. Blow your nose. Find something. That's crazy. But like, when I'm totally that person. Just like, Yeah, that's a lot.
Oh,
Oh, yeah. Didn't read it right, but. Oh, no, I.
Eric, I don't know where yours is.
Yes.
You know, for Eric. All right. So, there were people that had trouble with the tree diagram. Some people just missed like one of the things or a couple of the things. Most people had at least a little bit of the idea of how that works. When you have a total of 8 socks and 6 of them are white, then 6 out of 8 would be the probability. If you take out a white one, then that becomes 5 out of 7. So then you multiply those two to get the probability of white and white. Do the same with the red, add those two together, and that's it. Number 2 is like binomial probability. It's not exactly the same, but it has some similarities. That when you're talking about how many people have a certain probability of doing something, then you'd have, the probability of the thing multiplied by the probability of the next time, etc. So then if it's 4% to have a rider in a wheelchair, then if you say it's happened 2 times in a row, that'd be 4% multiplied by itself, or 0.04 to the second power for that one. Again, those are not really quite as common in our future as far as problems that we're dealing with. Most of the people did okay on number 3, the observed probabilities, but some did not. Okay, observed probabilities is when you take the number of people in the category and divide it by the total number. So, for example, how many people rated the LG phone high would be 15 divided by 30. There's 30 total people, 15 divided by 30, 50%. Okay, most people have that. Then when we say, how do we find the mean and standard deviation from discrete probability? Then we would look at the formula that says discrete random variable, and it has the formulas for the mean and standard deviation. Okay, so those are the formulas that you use for that. Some people did not understand it and did not know what kind of formula to use. And then, I mean, specifically, when I have these formulas listed for you, these problems are in the same order that we went through them in class, so that you would look, if you're saying, I need a formula for this problem, then you would look on the back and you say, okay, what's the first formula? All right, that's where it goes. Number 5. We did this one a couple of times. Some people, though, still have trouble with it. what are these different symbols when you're talking about binomial. This is important for us for this particular homework coming up, or that we had to do for today and in the future. Okay, so that when you ask a bunch of people a question, the number of people that you ask is n. And then the number of people who will say yes, like, did you visit Iowa yesterday or something, then the number of people who say yes out of that number, that would be x. But then p in the binomial distribution is the general probability of any individual doing that thing, whatever it is. And so in this case, it would be the probability of students attending a concert in La Crosse. And again, when I say that I want specifically for this situation, you need to reference the actual statement of the problem. It's not just number of successes. It's numbers of people who have attended a concert. Okay. So then number 6, finding the unusual values. Again, we have done this problem a few times. If we have a list of probabilities, then all we need to do is recognize which of those probabilities is less than 5%. So that's how we know it's an unusual event. All right, does anybody have any question about anything here on the first page? Okay, so if we go over to the second page, we've got, again, the binomial distribution, and I say find the mean and standard deviation. So you would look under where it says binomial probability, hopefully recognize the symbol for the mean, n times p, standard deviation squared of n cubed. So we'll make the connection between the statement of the problem and which formula to use. And then when we say, what are the unusual values of x? And I told you that it's bell-shaped, okay? So then we're looking at the empirical rule. So that if we know the empirical rule, then we say, take the mean minus 2 times the standard deviation. And then also take the mean plus 2 times the standard deviation. Those give you the interval where you're going to find 95% of the data is in here. So then unusual values would be anything below this number or anything above that other number. Now some of you still have trouble with the order of operations here. In the order of operations, you multiply before you do the subtracting. You multiply before you do the adding. Your calculator knows this. So if you just put the numbers directly into your calculator, you would get the correct answers. Some of you, however, you took the mean, subtracted 2, hit the equal sign, and then multiplied by the standard deviation. That's not what this is asking. And then you got numbers that were just completely wrong because they were so far different than anything that was given to you in the problem. Okay? So it's really important that you keep track of this order of operation and that you keep track of what the problem is actually asking for. Okay? So when you're looking at a binomial distribution where you have 320 people that you're asking a question, then the binomial distribution is telling you how many or what the probability is of getting a certain amount of success. So if you have 320 people and you say that this interval is 10,000 to 13,000, that just isn't sensible, okay? And I've said this before, and hardly anyone ever does it. If you get to a point when you're working on a problem and you get an answer and it doesn't make sense, it's better for you to write something on there like, this doesn't make sense because I know it's supposed to be somewhere in the hundreds instead of the 10,000. So I must have done something wrong, but I don't know what it is. It's better for you to write that note on there than it is to just leave it as it is, okay? Because if you write the note on there, then I know that you understand something about what kind of answer you're supposed to get. So then I know you at least understand what the question is about, as opposed to, I got an answer of 15,000, I guess I'll just have to write that on my test and hope for the best. If you know it's not correct, then it's good for you to let me know that you know that, so that I can get an idea of what you do understand about it. Okay? And that does come up here later with the z-scores as well. For number 8 then, once again, when we went through these in class, when I say, here's the general probability, I want you to find the probability of getting rain on 3 of the next 5 days. And this is right after the question about the binomial distribution. Then this is also a binomial problem. This is that binomial probability equation that's down below there. So it should be 5c3 p to the x, or p to the 3, q to the 2, right? So this specific problem number 8, you should be using that binomial probability equation for that. How do you know that? Because it's right in the section of the paper that's dealing with binomial probabilities. We haven't gotten to z-scores yet, so it's not a z-score question. There's no list of things, so it's not a discrete variable. It's got to be a binomial probability question. And we haven't used that formula yet. And so it seems reasonable that you would use that formula on this particular question. Unfortunately, a lot of people just didn't. A lot of people put 0.35 to the third, 0.35 to the fifth. But that's not what it is. It's that particular thing right there. Okay, so that was that one. There were a number of people who did better on the z-scores than I did on some other things. Okay? And it's important to understand the z-scores and how they compare to the areas. But for some people, all they got from z-score was you look it up on the table and you write down the number. But that's not how it works. You have to use the table numbers, and depending on what you're given, you have to maybe do something with them. As we had said, if I have z-score just less than a number, 1.6, that comes directly from the table. The table gives you areas that are less than or to the left of any particular value. But if it's greater than, then that's not what you need. And if it's between two numbers, you can't just look up those numbers on the table. You have to actually subtract them. When you have z-scores between two numbers, you try to find that area, then you have to find each area and then subtract those numbers. Now, some people had trouble when they did their subtracting, they came up with a negative number. It's impossible for you to have a negative probability. Okay? That can't happen. So if the question is asking what's the probability of something happening, and you end up with a negative number, that's not correct. Can't be. Same thing is true if I ask the question, what's the probability of something happening, and you say it's 4.2. It can't be 4.2. Probabilities have to be between 0 and 1. Now it can be 4.2%, but it can't be the number 4.2. So when you're looking at a problem, once again, if you're getting an answer and it's not sensible in the statement of the problem, then you need to be able to recognize that. Now I understand that for a certain situation, you might say, well, all I do is just get numbers and I have no idea what they mean. I understand, and I understand how that sometimes doesn't work. But the fact of the matter is, when you're going to get a probability number, it does have to be between 0 and 1. And if you get an answer that's not that, that should be an indication that there's something going wrong with whatever it is that you're doing. Okay. Then once we got into number 10, it was even more the same, okay? Because number 10, you have to use the formula for the normal distribution, x minus mu over sigma, in order to find the z-score. Some people, they found the z-score, but then they didn't actually find the probabilities. So then that's just one step in the right direction, but it's not very much. Part C of that, where you find the data values for the lowest 15%, that's a hard question. A lot of people missed it. It's not easy to understand, and I know that. Okay, but it's using that next equation, x plus z times sigma. You got it. Once again, the empirical rule is there. You need to understand that. And then for part E, I was surprised. A lot of people got part E correct, and they hadn't got other stuff correct. Say that again. That's the last equation. X minus mu over sigma divided by square root of n. Gives you the z-score, and then once again, you find the z-score. It says less than, so you just use the table number and put that in. Okay. So it is possible for me to make a mistake while grading, just as it would be for you to make a mistake while grading. So, does anybody have any question about anything on page 2? Okay. If you do have something that you want to talk to me over break or something, that's perfectly okay. Okay. Oh, I didn't bring those claws. Oh. All right. So that's that. Yeah. So everything we've done is preliminary to what we're doing now. And what we're doing now is preliminary to what we're going to do next. Okay. So a lot of what we did in the past, all of those things are kind of moving around now to fit into this thing called the confidence interval. Nope, this is what we did last time. So when we're talking about the confidence interval, we need to know what is the purpose of the confidence interval. How is it used? I want to know the use of the confidence interval. What does it do? It uses a sample to measure a population. Okay? So we're taking numbers from the sample, which we know are not actually correct, because they're just a sample. But from that, we want to figure out what's true about a population. And there are 3 different things that we're measuring right now. What are those 3 things? The proportion, the mean, and the standard deviation. So we have equations for those 3 different things. So what I'm really hoping is that those things are in your notes right now. The 3 major equations for the proportion, the mean, and the standard deviation, finding the confidence intervals for those things. So then, when we talk about proportion, and we're going to use population numbers and sample numbers and tables. Okay, for every confidence interval, then when we're talking about a population, if we use the letter P, which is a small letter p, the sample that we need is p hat, and the table that we're going to use is the Z table, which is table E. The next thing that we have is the mean.
Which one's the little p? I'm sorry.
The little p, this is proportion. Okay, so thank you, I appreciate that. We're going to add another column here, the measurement. What measurement are we doing? We're measuring proportion. The population proportion would be P. Sample proportion is p hat. When we do that confidence interval, we're going to be using the z table or table E in order to put that into our equation. Okay? What's the next thing? Mean. What's the symbol for the population mean? Mu. What's the sample mean? X bar. What table are we going to use? We're going to use the T table. Speed it up. What's the next thing? Standard deviation. Population standard deviation is sigma, small sigma. Sample standard deviation is S. What table are we going to be looking at? The chi-squared table, which is table G. All right. So when we're going through this process, we need to know specifically for the proportion, how do we get the numbers that we need for this? And specifically, when we say p hat is x over n. Number of successes divided by the total number of outcomes.
You're calling that p hat?
I am.
P hat.
P hat.
Here.
This is not the same as the general probability. The general probability is not the same as p hat. P hat is what we get from the sample. The general probability is something that we don't know, okay, but we're going to find an interval that we believe contains that general probability. So then, when we look at our list of formulas and tables, and we go to chapter 7, confidence intervals. Confidence interval for a proportion. Looks like that, which you already have written in your notes from last time. So then p hat we get by taking x divided by n, the number of successes divided by the number of people. And then q hat is just what? Q hat? 1 minus p hat. Yes, it is. And then we have to get this thing, the z-score of alpha divided by 2. We are not multiplying. This is not z multiplied by alpha over 2. This is a label. Alpha over 2 is a label telling us which z-score to use. So, for example, if I want a 99% confidence interval, that's telling me I want to be really sure about my results. So then I know that alpha is going to be 0.01. Because if I'm 99% confident, then I have a 1% chance of being wrong. Now, I don't have to go through and figure my z-scores for a lot of different possibilities, because in statistics, traditionally, we limit ourselves to just 4 different cases. If alpha is 0.05, then the z-score that we want is 1.96. If alpha is 0.01, 2.58, I believe. I'll check that one. And then if alpha is 0.10, normally I'd use 1.645. I could use 1.65, that would also be okay. So, what that is talking about, again, is how wide the interval is. If we want to be really confident, we have to make a larger interval, which means a bigger z-score. So you see how that works here. So then we put those things into the formula, we make that happen, and we get two numbers. Notice that we have the letter P in the middle. This is what we're trying to find. We're trying to find where this letter P is. Where is the population proportion? And it's going to be between two numbers. A number here on this side, a number here on that side. So the answer to the question, what is the confidence interval, will be P between two different numbers. That's what we want. All right, so any specific question about that right now? Okay, so let's do one. So we'll change this. Let's say I talk to 200 students and 75 like chili. Should say chili for breakfast or something, because that seems kind of low. Sure. Chili for breakfast. And I want to know what is the 95% confidence interval for the proportion. Okay, I'll give you a couple minutes, see if you can come up with those numbers.
P-hat is a sample, is that something that people actually like for breakfast?
Okay, when we say p-hat, we're going to take the number of people who said they liked it and divide it by the total number of people. That's p-hat. And just to reference this, okay, you're not going to round off very much until you get to the end of the problem. You should probably keep around 6 decimal places, or, about 6 decimal places as you go through here, just to make sure that when you get to the end, you're going to be rounding off correctly.
How do we find the Z output thing again?
Okay, so what we're looking at here is if it's a 95% confidence, then alpha is 0.05. If alpha is 0.05, that z-score is 1.96.
We don't need the table because we already know that, right?
That's correct.
How many decimals did you say, Jen? Oh, the total.
I'm sorry, what?
How many decimals at the end do you want to?
Usually 3.
3.
All right, so it might be reasonable for you to check with your neighbor and see if your neighbor has similar stuff to what you have. I recommend very highly that you stop working on the problem and look at what somebody else is doing to make sure that what they and you are doing is correct.
I got 308. So my, I know, more shallow, you know. It's much gentler now. It's much gentler.
Did you say you wanted to go to 2 decimals at the end?
Probably 3.
3? I can brush you.
I know, but I want to apply it there, but like I was scared because I don't. Right. I just want to. No, why does it apply there? Why does it apply there? Save money. I don't know. It's like 3 hours. But I just. I've had it. Oh, it's not the square root of n, it's just the square root of n. I was looking at different one.
There is another one.
Yeah. Like flat. Then that's why.
All right. Alicia Bell, what do you have for your answers? Okay. Evie, you got answers? Oh, okay. Amanda, still working on it. All right. I'll give you another 15 seconds. See if that'll help.
I think that.
Oh, you're good enough individually. I just took the whole thing right in. You don't even know that I would be involved.
Yes.
1.9.
That's right.
And then, yeah, and then do.
Oh, you did.
All right, Alicia Bell, you got numbers you like now? No? Okay, can you tell me what p hat is? P hat is 0.375. Can you tell me what the z-square we're going to use? If alpha is 0.05, which it is, z-square is 1.96. So that's the number that goes right there. Okay? So, Alicia, does that make sense? Okay. Evie, do you have numbers you like? For an answer? Okay. Can you tell me, did you get this 375? Okay. Did you get this 1.96? No. Okay. All right. So, let's see. Who's the third person name? Amanda. Did you get this? Did you get that?
Yep.
Okay. Then this thing here is under the square root symbol. Can you tell me what you have for numbers there?
0.375
Yep.
times the 0.625
That's right.
divided by the 200.
That's correct. Okay. Did you get an answer from that?
Yep, 0.308.
Yep, 0.308.
That did 4 decimal places instead of just 1.
Yes.
That's my go-to number.
All right. Let's see. I'm struggling here. Just a minute. Evie, do you see that? Did you get that? Okay. All right. Emily Yang, did you get that?
Yeah.
Okay. So do you understand where those numbers came from?
Yeah.
Okay. All right. Other question?
She just needs help plugging it in her calculator. It's not.
Oh.
Because if I enter it the way that it's written on the paper, like if I do 1.96.
Okay, hang on. Let me see your calculator.
You gotta use parentheses.
You gotta use parentheses. Yeah. Okay.
Touching it.
Oh my goodness, right?
Okay. Go ahead. Okay, stop. Are you gonna start here or are you gonna start here? Okay, either way is okay. But let me see you do this. 1.96 parentheses.
My answer.
So where,
Right there.
right, where in this process are you putting that?
After the square root.
After.
Because you're gonna take the square root of all three of these ones. Okay? So do you see where I have the square root symbol on the board? All three of those numbers are inside.
Right.
So that means that if you do all of this, that whole thing has to be square root.
So I put in times 0.375.
Okay.
Or I put another times 0.6.
Yes?
Well,
Please start over, because I don't know if I had time.
Okay, I want you to turn it on.
I got the
Okay, times. Calculator knows that.
Yeah.
The calculator was a little bit smarter. Hey, you should do that, for instance, and put it this way.
We like for the bed.
Yep.
Okay. Oh, don't.
There you go, yep, and that's the answer for that, okay? So that goes. All right, there we go. All right, anybody else have a question about how to get this 0.308? Okay, so then the one on the other side is 0.442. All right. Any further question about getting these numbers right here?
The formula, so that's called the proportion formula.
That's confidence interval for proportion.
Okay.
Okay. Now, it would be a reasonable question then to ask, what does this mean? What this means is that when we did the survey, we came up to get an answer from the sample. P-hats was 0.375, or about 38%. So if we say, how many people like chili for breakfast? About 38%. But that's not the value for the population, that's just for the people that we talked to. So if we say, I was talking to students, I want to get an idea of what the actual number would be for every student, not just the ones I talked to. What is that population proportion? That's somewhere between, if we round off, 31 to 44%.
That's the number you got for the second part of that?
Yes, it is. Did you get the 308?
Yeah.
Okay. Same thing on the other side, except for the plus sign.
Right, that's what I was gonna recheck your name.
Okay. Now, is this very accurate? If I say that people who like chili, it's somewhere between 31 and 44%, is that a very accurate interval? Depends on what you want to do with it, right?
I'm not getting that number.
Okay, let me see what you got.
Breakfast.
Yeah. So, yeah, I would. If it's not lunch, it's on set, right?
That's what it's called. So.
So, if we were talking about, am I going to try to market breakfast chili to people? And I would say, oh, well, it's somewhere around 38%, maybe somewhere between 30 and 45%. Okay, no big deal. But if I wanted to be more accurate, what I could do would be to change the sample size. I would talk to more people. If I talk to more people, I would be able to get a more accurate result if I needed to, for some reason. Like in a political campaign, if they're close to being 50%, maybe I would want to get more accurate numbers. So I would ask more people in order to get more accuracy. So then what I would have is the sample size problem. Sample size.
This is a different problem now?
This is a different problem now. We're doing a sample size calculation. Oops. Sorry. So what we want to do now is a different problem. We're not finding a confidence interval. We're trying to find a sample size with a certain accuracy of confidence interval. So I think about my situation and I say, well, I just want to do a 90% confidence interval, but I want it to be accurate within 2%. I want to be a lot more accurate than what I have right now, but I'm just going to say a 90% confidence. So now I'm going to use this information. I have to know my p hat and my q hat in order to make this work. In the textbook, they will tell you, which is the case, if you don't know p hat and q hat, you pretend they're 50%. Do that. It doesn't matter here because we already have our p hat and q hat. If we didn't have them, we would just make them 50% and that would work. But now I want to be able to find out this sample size. I want to figure out how many people I would need to ask in order to get this amount of accuracy. Okay? So I'll give you a couple minutes and see if you can come up with this answer for the sample.
Do we turn the 2% to a decimal?
We do.
One point six five or future,
We can use that, or we can use 1.645. Either one's okay.
which one's lowest?
It doesn't matter. You can use either one.
What's that E mean again?
That's the amount of error, or the margin of error. You have to be given it.
If we're not given it,
You don't. You have to be given it. The only way to do this problem is if somebody tells you how much accuracy you need.
so what are we doing right now?
Right now, I have the accuracy up on the board.
2%.
Yes,
So is that the margin of error?
it is. How accurate do we need this result? We don't. We don't need this accurate result.
Will you change the
We're just
2%
ballparking this.
into a decimal?
Yes, we do. I don't want you to think about rounding this off at all, because the accuracy of this doesn't matter at all. So then if I ask you a question, how many people do you need to survey? You're going to give me a ballpark estimate. You're not going to give me an exact number, because it doesn't matter.
I remember you said when we're talking about people, go to the whole number.
That's usually correct. Yes, it is. But in this case, we're just ballparking. These numbers are going to be constantly changing. There's no way we're going to say, I'm going to survey this number of people and then stop. I'm going to survey whoever I survey. But this is a ballpark estimate of how many people I know. Okay? The answer is approximately 1,600. Either 1,585.56152 or 1,595.21484. But neither one of those numbers is meaningful. This is a ballpark estimate. 1,600, close enough. Now, let me just say this. I'm going to try to keep a positive atmosphere. if you constantly ask me how accurate your results are going to have to be at the end, I'm going to get increasingly frustrated. Okay? I'll tell you how accurate things need to be. You don't have to worry about that. Okay? All right. So you should get this number. 0.375 times 0.625 times 1.645 over 0.02 squared, or this could be 1.65, doesn't matter. And then this is about.
Why is that 1.65? The number that I got.
This number is because it's a 90% confidence.
Right.
90% confidence intervals have z-scores of 1.645 or 1.65. When you meet our little list,
Well, that's the list I know.
and on the list, did it say 1.645 for 90%?
No.
Oh, then that is not right.
Well, because don't you do the 0.1 divided by 2, right?
I do. That's 0.05 is the area. So then if I look for that on my z-score table,
I did 0.05.
okay. So you should not have done that. You should have just looked at the list instead of trying to figure it out. All right. Question.
Okay, so with like these types of problems, do we just round to like the next biggest?
It doesn't matter. For sample size, okay, for sample size calculations, it doesn't matter. Okay? Because what are you going to do? Are you going to get to 1,586 people and say, oh, I've got to stop? No. You're just going to kind of get up in there. So it's not something where you're like, it has to be this number of people exactly or else I'm not going to get my results. You're not going to get 0.375 when you do the next survey anyway. So these are just play numbers.
So like, I have another thing on a test, if I just wrote like what was in our calculator with that. So we accurate number. Or, like,
Yes.
on the homework? Okay.
Yes. And specifically on the homework, they're going to tell you
Okay.
to whatever thing,
Okay.
right?
Yeah.
But does it actually matter? No, not at all. All right, so we did P. Now we're going to do So what do we got for T? Well, there we go. So let's say that we're checking our sales figures from, oh no, it's not sales. Let's do of 16-year-olds in extracurriculars. Okay, and we're going to do a survey. 28 schools. And we have a mean of 55 and a standard deviation of 120. Well, let's say it's 55.8. Standard deviation of 20. And I want a 95% confidence interval for the mean. Now, when we ask the question, how do I do confidence intervals for the mean? Then I have a different formula for that. We're still in chapter 7. Oops.
Now we're doing mean problem.
Now we're doing a mean problem. Yes, we are. Well, why isn't it giving it to me? All right, there it is. Now, in the textbook, they talk about using the z-score possibly, but we're not going to do that. We're just going to use the t, confidence interval, for the mean. All right. So, you need to be able to see something like this and to be able to recognize what the symbols are asking you to put in. X bar is the mean of the sample. S is the standard deviation of the sample. N is the number of data values or data items. And then T with the alpha over 2, that's not multiplying T by alpha over 2. That is a label for which T do we need.
Can you go through those one more time?
Sure. X bar is the sample mean. S is the sample standard deviation.
Sample deviation.
Sample standard deviation is S. N is the number of data values or the sample size. And then we have a T value with the label alpha over 2. So we need to find that T value. And so we need to know what alpha over 2 would be in this situation. Jackie, can you tell me how I'd find alpha over 2 for this particular situation?
Well, so you want 95%, alpha is 0.05.
Okay, so what would alpha over 2 be?
.025.
0.025. And we're not looking at the z-score now, we're looking at the t value. So this is table F. We look at those tables. And I want to know where to look on those tables.
Do you have to break it down like that, or can you say, since you know it's 95% confidence, just go to the 95%?
You can. But when you do chi-squared, you can't. So might as well do it. All right, so here we are, 95% confidence interval. So when we look at the t distribution, table F, we can just look at where it says 95%. That's handy. So then we go from the 95%, we need degrees of freedom. Right? So, Taylor, can you tell me how to find degrees of freedom here?
You have to go to the t distribution table.
No, I want to know what the degrees of freedom are for me in this problem. That's correct. So in this case situation, n minus 1 would be 27. 28 schools surveyed, so we go to 27.
Minus what?
And then 1.
You said that was 28 minus 1?
Yes. Taylor, you got that number?
It is
2.052.
It is 2.052. That's the 95% confidence interval number with degrees of freedom 27, 2.052. So that is going to be my T of alpha over 2 is 2.052. So now we want to put those numbers into that formula and make that happen. So I'll give you a minute, see if you can do that. Come up with my intervals for the T value. Lower and upper.
Cause like, I feel like it's really inconvenient for you to turn around, so every time you turn around, it's really uncomfortable.
All right, Liz Peterson, what do you
It
got?
always looks really uncomfortable when you turn around. I could start asking you.
Okay. And usually we would go to 3 digits of accuracy, but it doesn't really matter. Okay. So 47.9 and 63.7. So here we would be saying, I know what the sample of these 28 schools, it had an average of 56, more or less. But that's not the actual value for schools in general. Even though it's for these 28 are part of a larger group. So the larger group would have an average somewhere between 48 and 64, more or less. Okay.
Can you give me a second to make sure I get those numbers?
Well, yeah, actually, we're going to take a break right now. So 4:26 is when we'll come back. And we'll do standard deviation. And then we'll talk about our new stuff. Hi.
All the ones that are not wrong.
Oh, yeah.
And